Sometimes in MATLAB, we want to test a condition and then run one block of code when the test is found to be true, and a different block of code when that test is found to be false. That's exactly what if-else statements in MATLAB are designed to do. The basic syntax for an if-else statement involves three keywords. The first is the if word, so we type if, return, then we type the word else, E-L-S-E, then we return, and then we end our statement with the word end. In between the word if and else, we're going to write a code block. We'll call that code block 1. In between the word else and end, we're going to write a different code block. We'll call that code block 2. Then we have one condition that we're going to test. That condition is encoded as a logical scalar. In other words, a 1-by-1 array that's stored using the logical data class. Remember, the assigned value of that logical scalar could either be true, in which case the logical value would be 1, or false, in which case the logical value would be 0. The point of this structure is, as we test our if statement, if that logical scalar gets true, we run all the code inside code block 1. Else, if it's not determined to be true, if this is false, we run a different set of code under that condition. Then we end our statement and we continue on with our program. Let's take a look at our first example where we're going to test a random number between 0 and 1 to see if it's actually less than a half. So in this case, we're going to use the function rand. Rand actually produces some random number between 0 and 1. If you want to read more about that, you can always type doc rand, and that will come up. Returns a single uniform distributed random number in the interval 0 and 1. So specifically, we're kind of rolling the dice, and then what we want to do is check, is that number less than 0.5? So we'll write an if statement. Remember, we say if the result of that random integer is less than 0.5, we'll go ahead and run one line of code. Else, we'll run a different line of code, and then we'll end our entire if statement. Here, we're going to display one of two messages depending on what the value of num is assigned. In the case that num is indeed less than 0.5, in other words, that logical scalar evaluates as true, we're going to display the message, you are less than 1/2. Otherwise, we're going to display the message, you are greater than or equal to 1/2. Let's go ahead and run this. Notice if I push run, first thing that happens is you are less than 1/2. So if I put num was 0.0318. That indeed evaluates as less than 1/2. So this condition evaluates as true, and we dropped into the first code block in our if-else statement. Let's run that one more time. And in this case, we notice we get you are greater than 1/2. Notice that num is 0.8235. That is not less than 0.5. So the condition here evaluates as 0. MATLAB does not run the block 1 code, but instead drops into the else condition and runs the block 2 code, which is exactly what we see in this flowchart. In other words, the major difference between a simple if statement and an if-else statement is when the condition evaluates to be false in an else statement, we actually insert a block of code that runs in that situation. Let's take a look at a second example of how to use if-else statement. In this case, we're going to check if a given scalar input by the user is even or odd. To run this test, we are going to query the user. We're going to ask the user to give us input using something called the input dialog function. To learn more about the input dialog function, simply go to the command window and type doc input dialog, push enter. That brings up the documentation. Notice this creates a dialog box to gather input from the user. The syntax of this particular function is one of many forms. We're going to focus on the second, which is answer equals input DLG, that's input dialog, open parentheses, prompt, comma, DLG title. Let's go down to the description that actually describes what's happening there. We'll read the first one. Answer equals input dialog creates a modal dialog box containing one or more text edit fields and returns the value entered by the user. The return values are cell arrays of character vector. That's a lot of technical language. In order to learn more, click on modal, kind of think about what's happening, but I'll give you a quick synopsis here. What this is saying is MATLAB will produce a dialog box that looks like this and actually comes front and center to the user where I can input data. MATLAB will not run any other line of code until I input that data. In other words, a modal dialog box prevents a user from interacting with other MATLAB windows until that user has responded to the dialog box. We haven't really talked about cell arrays, but just notice that the answer is not going to be a number. It's going to be a cell array. So we're going to have to do a conversion 1, which we'll talk about in just a second. When we have prompt in 1 and then dialog title, that specifies the title for the dialog box. Specifically, notice in this situation that the dialog title is input, and right at the top of that box, we actually see an input. Do you see me teaching myself how to use this function simply by reading the documentation? That is a deliverable of this course, and I hope you've seen that example multiple times. Let's go back to the example that we're running here. So here I have a prompt that says enter a 1-by-1 integer value. Then I have a title that says even or odd test. Then I'm going to have temp equals input dialog prompt/title. Let's run that code in the command window to test what happens. The moment I do that, MATLAB creates this dialog box, which has my prompt, enter a 1-by-1 integer value. And then literally I cannot use any other thing in MATLAB because this is modal. It kind of has command of my use of MATLAB. Let's go ahead and enter 5 and push OK. In this situation, if I look at the value of temp, notice this is a cell array. Specifically, if I were to test, is this variable a numeric variable? So I can go is numeric temp. Notice that's going to get a logical 0. In other words, I can't actually use numeric functions on that variable. So specifically what I'm going to do is I'm going to now typecast, I'm going to change this from a cell array into a double. To do that, I'm going to use the function string to double, which is going to take in the temporary variable and then output a new value, user number, which is literally the value of the input temp, but instead of as a string or a cell array, it's going to be an actual number. So let's go ahead and check that line of code. We'll run that down here. Remember, temp was this cell array that is stored 5, but the user number now is a numeric 5, and we can test that. Is this new user number variable numeric? And indeed, MATLAB is saying that yes, that is a logical 1. It is numeric. Now what we want to do is we want to use that user underscore num to test whether or not it's even or odd. So in this situation, we're going to use an if-else statement to produce our result. So we'll type if, the word else, and the word end. Let's go ahead and set up our condition. In this case, we're going to use this remainder function, and we're going to test what is the remainder of the user num when I divide by 2. Well, we know that an odd number would have remainder 1, and an even number would have remainder 0. So specifically, if I said that the remainder of this function is 0, in the case that that remainder actually does evaluate at 0, we're going to print out the message, your number is even. Otherwise, we're going to print out the message, your number is odd. Let's go ahead and run this code to test it. MATLAB produces this box. I'm going to go ahead and push 4 in and push enter. Now MATLAB stores that in temp, converts temp to a number, checks whether or not the remainder of that number when we divide by 2 is 1 or 0. In this case, we know that the number is 4. 4 divided by 2 is 2, and there is no remainder, so the remainder is 0. So now we print out your number is even. We do not actually print out the else conditions, and we go down to the end of our code. Let's run that code one more time. In this case, we'll use a different number, so maybe we use the number 7. Let's push OK. MATLAB calculates the remainder. The remainder of 7 divided by 2 is 3 1/2. In other words, it's 1. So that 1 is not equal to 0. This condition is false, so we drop down into the else and we print your number is odd. Let's go ahead and run this one more time. And in this case, we're going to assume that our user is a bit devious. So suppose that I did not enter an integer value. Let's say that I entered 3.25 and I push enter. My code currently is producing your number is odd, but if I actually look at the number stored in user number, it is 3.25. That is not neither an even nor an odd number. Specifically, if I were to actually test this, notice that my remainder is not 1 or 0. One thing that I could do to get around that if my user was devious is actually round that number. So specifically, I'm going to round down or round up. So now I push round that number, and now I do this user check. If I were to go into this, notice that immediately what happens is if my user enters a non-integer value, I round it towards 0, and then that actually allows me to check. I might want to document that in my prompt, but specifically, I don't get into the situation where my code is doing unintentional thing. Now, if I go back to this case and I enter my 3.25. Notice that number is indeed odd because 3 divided by 2 has a remainder of 1, so now I've checked this. The other devious situation that I could run into is a user could enter a y value rather than a number. When I push enter, MATLAB says that your number is odd, but y is not an odd number. Specifically, if I were to check what is user num, notice this is NaN, not a number. And the reason it's not a number is when we went to go convert this string to a double, well, strictly speaking, when my user input into the value y, that is not a number. So when we do that conversion to a double, MATLAB stores that as NaN, not a number. One way to get around this in my code is actually to create a error check if statement before we drop into the if else. So what we're going to do is do if end, and then we're going to say, is the user number an NaN? So is NaN user number? That means please test the user number to see if it's not a number. If it is not a number, we're going to produce an error message. So specifically, we're going to say, oops, my sources say you did not input a 1-by-1 number. And then we're going to stop termination of that code right at this spot. Let's go ahead and try to be devious again and see if we've checked for that error. Here we go. Let's put y in. So we're trying to be devious and we push enter. Oops, my sources say you did not input a 1-by-1 number, and immediately MATLAB stops execution and no longer drops down into the rest of this code. That's what that return button does. Notice that we're using an if statement to do error checking, and then the if else does the actual return of what we wanted in this program. Let's try that one more time, and in this situation we will indeed enter a number rather than being devious. So let's put in 5. MATLAB takes the input, stores it in temp, translates temp into a double, rounds that double to the nearest integer, and then stores that in user number, checks is user number not a number? No, it is not. So that evaluates as false. We skip over this block of code. We go down to this block of code, which says check the remainder between user number and 2. If the remainder is 0, print out this one. Otherwise, print out this message. Well, in this case, 5 divided by 2 has a remainder 1. That is not equal to 0, so this value gets false. Then we drop down into the else condition and print out your number is odd, which is exactly what we've seen here. Let's move on to yet a third example of using if-else statements. In this case, we're going to create a check to see if two numeric arrays have the same size. We'll start this code by actually defining two arrays. We'll call them x and y. And what we want to do in this code is actually check, is the size of x equal to the size of y? Let's go ahead and write an if-else statement to check that. So what we will do is say if, else, and then n. Now what we're going to do is produce a condition that compares the two sizes of these vectors. Specifically, we're going to say, does the size of x equal the size of y? But this is where we have to be a little bit careful. Remember that the size of x produces a 1/2 row vector, so too does the size of y. Specifically, if I define x equal 5 and y equal -4, when I take the size of x, that's going to be 1 by 1 because it has one row and one column. If I take the size of y, that's going to be 1 by 1 because it has one row and one column. Then if I create the logical test, size of x equal size of y, I'm basically asking, is this 1/2 row vector equal to this 1/2 row vector? But remember, this operator, when operating on row vectors, is going to produce a logical vector out. So when I push enter, this logical array has 1, 1. Remember though, in an if statement, I need this to be a logical scalar, not a non-scalar logical vector. So what I can do in that situation is say, the only way that these sizes are equal is if all sizes match. This is where I can use that logical operation all. Specifically, if we were to test this, MATLAB will return a true when all values of the output logical array are equal to 1. Let's go ahead and test that. Notice all values are 1 in that situation. Let's make sure that our logic is sound here. So I'm going to change this thing to a row vector. Suppose we say 5, 1. Let's go ahead and copy this and go down to our command window. Those are not equal because this is a 1/2, that's a 1 by 1. When I actually run the sizes, let's go ahead and run that line. Notice one of the sizes is equal, but the other one is not equal. That's not what I'm trying to test for. I'm trying to make sure that all of the sizes, the column sizes and the row sizes, are identical, and that's why I use that function all. Now, this is a logical scalar. When I copy and paste, the condition on the if statement will be true only when the size of x equals the size of y. In that situation, we're going to go ahead and print nice, these arrays have the same size. If, on the other hand, this condition evaluates to be false, we're going to print an error message that says these two arrays have different dimensions. Let's go ahead and test this one more time. In this case, what we'll do is we'll create a column vector and a row vector. Those have different dimensions. When I run this, I actually get my error message, which was what's desired. Last thing that I want to note is that this code might actually misbehave. Remember, MATLAB is an array-based language and all data types are stored as arrays. So let me show you some crazy results that we can get here. If I were to write the word test, that's going to be a character array with 1, 2, 3, 4 entries. It's going to be a 1x4 array. And then I could actually, using a different data class, perhaps logical, store a vector. Let's go 1, 1, 1, 1. So this is going to be a 1x4. Here's a claim. When I run this code, it's going to produce that x and y have the same dimensions. So I'm actually, in the first case, the size of x is identical to the size of y, both in the rows and columns. So we actually evaluate this body of code. But that's not really what I wanted to do in this situation, at least in my mind. What I wanted to do is compare the sizes of two numeric arrays. To do that, we'll add another if statement. This if statement is going to be designed to test whether or not the input variables are doubles. Specifically, let's go ahead and write if and then end. This is going to be a simple if statement, so only one condition inside the body of this if. Specifically, we're going to go ahead and test whether or not x and y are doubles. And if either x or y is not a double, we're going to produce an error message and then stop execution of our program. To accomplish this, let's use the isA function. So we'll go ahead and ask the question, is the variable x stored using the double data class? If it is not, we want to produce an error message. But remember, not only are we trying to guarantee x is a double, we also want to guarantee y is a double. In other words, if x is not a double or y is not a double, so in other words, we're going to ask, is y stored using the double data class? If either x or y are not stored using double data class, we're going to produce an error message that reads, whoa, this test is limited to arrays that are stored as doubles. And then we're going to return. In other words, we're going to stop execution of this program completely. Let's run this again with this additional error check. When we run this program, notice x is stored using the char data class. Y is stored using the logical data class. So in this case, we have, is x a double? That becomes 0. Not 0 becomes 1. Is y a double? Is 0. It's false. Not 0 becomes 1. 1 or 1 is 1. So that condition, the logical scalar in the first if statement, is triggered. We drop into the body. The body prints out this error message, which says, whoa, this test is limited to doubles. And then we return, and no other lines of this code are executed. Let's go back to our original model where we were going to test two numeric variables stored at doubles. In this case, we'll use column vectors. So let's use a 2x1 column vector for x. And we will also use a 2x1 column vector for y. Perhaps we say it's -4, second row is 5. When we run this, notice, first thing that we do is check, is either one of these not a double? Well, in this case, x is stored as a double, so that gets 1. Here, not 1 is 0. Also, y is stored using doubles, so that gets 1. Not 1 is 0. 0 or 0, the logical scalar gets assigned a 0 value. The moment that the logical scalar in the condition of our if is 0, we skip that block of code completely, which is why it's not printing out in our command window. We drop down to the second if-else statement in this case. Then we check, is the size of x equal to the size of y? Well, in this case, the row dimensions are equal and the column dimensions are equal. Remember, the all function produces a true only when every individual logical scalar in the entire input is 1. So in this case, we're saying all of these are the same. This produces a 1, which means we drop into the first code block in our if-else statement, and we produce nice. These arrays have the same size, which is exactly what we see here. On the other hand, if I were to move one of these to a column vector and one of these to a row vector, notice when I run this program, the logical scalar for the first simple if statement ends up to be false based on what we just said earlier. So we skip this body of the if statement here. We drop down to the second if-else statement. In this situation, we see that the size of x equals the size of y produces a logical vector, which is 0, 0. Remember, all of that logical vector will be true if and only if every single entry of those is true. But in this case, we have 2 zeros. So this produces false. The moment we know that the logical scalar in the if statement produces false, we drop into the second code block and we produce this error message. The two arrays have different dimensions. That's exactly what we see printed in our command window. And there you have it. In this third example of using if-else statements, we've created an error check to test whether or not two vectors have the same dimensions. We add an additional error check to test whether or not the vectors that we're working with are stored in the double data class. This type of error checking will come in helpful later as you write your own matrix functions. That's one of the units of this class. For now, though, I wanted to show you one of the main applications of if-else statements. Let's take a look at our fourth and last example of using if-else statements. We're going to design a game that allows a user to decide whether or not they want to play, and then to try to guess a number between 1 and 10. If they guess correctly, we give them a small prize, which in this case is going to be a printed output in the command window. We'll go ahead and initiate the winning variable to begin with. So we'll call win a pseudorandom integer between 1 and 10. This is a 1-by-1 integer. Remember, we've seen this call in previous videos. Then we're going to use our menu function to prompt the user to tell us whether or not they want to play a game. In this case, the prompt we're going to use is, would you like to play a game? Remember from our discussion of the menu function, we can actually save the choice of our user based on this prompt. So we'll go ahead and call the menu function. We'll do this on the menu prompt that we've just defined. That first argument to the menu function is going to print out that message in the menu box that we generate. In this case, we'll have two options, only two options for the users. Either yes, they can play the game, or no, they're not going to play the game. Let's run this code and see what happens. The moment that I run this, MATLAB produces a menu dialog box and I can choose either yes or no. Let's choose yes. After I've done that, user choice is now in memory. Notice in this case, I am obtaining 1 because I chose the first of those options. Now, depending on what our users respond, we're going to do one of two different things. Let's suppose that we're going to check using an if-else statement whether or not our users want to play. So what we'll say is if user choice equal 1, that indicates that the user indeed wants to play. Else, if user choice is not equal 1, that means that the user does not want to play, which means in code block 1, I'm going to include everything having to do with the user wanting to play, and in code block 2, I'm going to include anything having to do with the user not wanting to play. The situation that the user doesn't want to play is much easier. Specifically, we're just going to go ahead and report, okay, thanks for responding, goodbye. So assuming that we run this menu, they choose no. The code block that we're going to print out is that message. Let's go ahead and run that. And then in this case, we're going to choose no. Notice the moment that I choose no, I drop into the else condition because user choice in that situation would be 2. 2 is not equal to 1, so that condition evaluates to be false. We skip code block 1, we drop into code block 2. Code block 2 outputs that message in the command window, which is exactly what we see. If, on the other hand, our user says yes, they do want to play, in other words, user choice is stored as 1, we're going to use an input dialog box, which we've seen in a previous example, to prompt the user for their guess for input. In this case, to do that, we're going to define the dialog prompt. Please guess an integer between 1 and 10. That's the thing that the user is going to read in that little dialog box. We'll also title the box called guessing game. And then we'll get the guess by setting the variable user underscore guess equals input dialog. That's the function that produces the dialog box. And then we're going to use the prompt defined here and also the title guessing game. Let's run this code again. Here we've produced the menu. Let's go ahead and play this game. The moment that we've chosen 1, MATLAB drops into this first block of code and it says title guessing game. Please guess an integer between 1 and 10. In this case, I don't even know what the integer is, and I actually can't check because I can't interact with the command window, so I'm literally trying to guess here. Let's suppose that it is, I don't know, 3, and we'll push OK. In this case, win was actually 2 and user guess was 3, so that would be a false. Notice, however, that user guess is stored as a cell array. We've talked about that. The output input dialog is actually stored as a cell array, but we're trying to compare a double to a cell array. So specifically, we're going to do a conversion. We're going to go ahead and convert the user guess output from this cell array format into a double format, and we'll call this string to double, and the input of that is going to be user underscore guess. We can test that line of code in the command window, and notice that guess is actually stored as a double. So guess is guess a double, and MATLAB returns yes it is. Now I have a double based on the user input. I also have a double that is determined by the original setting of this variable, the selection of the winning number. And here we can get really creative and actually embed an additional if statement inside our other if statement. So let's go ahead and write if else end. Notice we're embedding that inside the block of code where the original if condition is true. What we're going to say is if guess is the same thing as win, we're going to produce a message that says, winner, you won this game of chance. On the other hand, if guess is not the same thing as win, in other words, if the user guessed something that was not equal to the choice of our program, we'll produce a different message which says, you did not win, better luck next time. We really should say stop gambling, but this is a toy example, so I don't feel so bad about it in this situation. Let's run this code again. The moment we run, we put up this menu box. We have two choices. Would you like to play a game? In this case, yes, I would like to play. MATLAB prompts me, please guess an integer between 1 and 10. I'm going to go back to 3 and try again. Now I push OK. Oh, what are the chances? About 1 in 10. I did not win, better luck next time. Specifically, the win variable was set at 10. My guess was 3. I would be willing to bet that if I just continue to play this game over and over and over again, I would expect my win rate to be 1 in 10. When I compare my game to the California lottery, the chances of winning my game were actually a lot better. So maybe I should start collecting revenue and then apportioning it to local schools. I don't know. Regardless, what you're seeing here is that we can actually nest if-else statements, and the block of code inside each code block 1 inside the if statement and code block 2, can literally include any executable programming statements. In this case, we have this nested if statements inside other if statements. This last example is the most complex single programming project that we've taken on so far. If you actually go back and watch how I did this, we actually modularized our code. We designed portions of our code and tested those as we were running it. That form of development is a good habit. We'll talk more about that as we talk about program and algorithm design. The point though is that we don't write a huge line of code without testing it and then just pray that it works out all right. We break large projects into smaller projects, test each of the smaller projects individually, and then compile them together to form the larger project. Let's do a quick recap. If-else statements have really 3 key words: the word if, the word else, and the word end. In between the word if and else, we say that that is code block 1. In between the word else and end, we say that that's code block 2. Right next to the word if, we put a space, and then we have a logical scalar which checks a particular condition. If that logical scalar returns true, we drop into code block 1 and execute all lines of code, skipping over the else condition. On the other hand, if our logical scalar returns false, we skip over code block 1, drop into code block 2, and execute all programming statements found in there. The flow chart, again, is we check our condition. If it's true, we drop into code block 1. If it's false, we drop into code block 2. In both situations, we drop after the end and continue with our program. That leads very nicely into our community challenge for this video. On the left-hand side of our screen here, we have a flowchart diagram for a simple if statement. On the right-hand side of our screen, we have the flowchart diagram for our if-else statement. Why is it useful to have the additional functionality of if-else statements rather than just simple if statements? What applications would require us to use if-else statements rather than just being able to do stuff with if statements? What is the additional efficiency or the additional use of being able to do if-else statements? You can write your own responses in the comment section below or link to other people that have written well about this. Of course, I always welcome your questions, comments, and concerns. When you give me feedback, I become a more effective content creator. Thank you so much for your attention, and I'll see you in the next video.